So 7.5 has to do with properties of logarithms. We're going to do a couple different things with this. One, we're going to just practice using the properties. And two, we're going to solve logarithmic equations using those properties as well. So we're going to just play around with the properties and then we're going to actually apply them.
What is this half of the chapter 7?
The easy thing to kind of keep in mind here is, again, a logarithm is just a power. And so the exponent rules that you already know that have to do with multiplication, division, and power to a power, those are going to be very close to the properties of logarithms as well. So hopefully it'll make it easier to kind of remember them. Okay, so we're just going to go through the first property and I'm going to talk it out, and you can take a screenshot from your book or you can take a picture of the screen. It's up to you. So go ahead and do that and get it situated in your notes, and then we'll talk about this particular property. So this property is called the product property. Alright. And if we look at the sort of general form of it, what it's basically saying is I can take one log and turn it into two logs using the factors of the number. Okay. In this particular example down here, they've already broken it up into factors. The original problem would have looked something like this. Log base 2 of 30. And then I could break it up into its factors, 5 and 6, and separate them by addition. So when we're dealing with a product or multiplication, we can separate them into two logs using addition. And the way that that's similar to our exponent rules is whenever we multiplied two exponents together that had the same base, we added the powers. Okay? So remember that the logarithm is just a power, so I'm really just adding powers. So when we multiply exponents, we add the powers. When we break up a logarithm into its factors being multiplied together, I can separate them using addition. So it's that sort of relationship between multiplication and addition that we've already been used to that's going to come into play here. And the reality is you're going to be given some values for certain logs, and you're going to have to use those to evaluate a given problem. And we'll go through some examples.
So basically when you add...
And the key thing here is that we can go in both directions. So if I was given this, I could condense it down into one log. And we're going to do that when we solve equations. So we're not there yet. So here's an example that we're going to do. Okay, at this point we only have one property. We're going to go over two more properties. And actually we're going to do this problem again later on using one of the other properties that I'm going to show you. So when you get to doing your own homework, you can choose which property you want to use. Now here's the key to doing this. In each of your homework assignments problems, you're going to be given a certain value, that log equals some decimal. And then your goal is to use what you've been given to evaluate the problem that you've been given. Now, the key thing here is that the only thing I know is that I need to use 2 to simplify this 32. So I want to figure out what the relationship between 2 and 32 is first, and use multiplication. So how can I get to 32 using only 2?
16.
I can only use 2. How can I create the number 32 using multiplication and the number 2? Yeah, Maria?
16.
Wait, 2 to the 5th?
Okay, 2 to the 5th, but that's exponents. So how would I use it as multiplication?
2 times 2 times 6 times 2.
Jackson, say it again.
2 times 2 times 2 times
2 times 2 times 2 times 2 times 2. And this is the reason I'm showing you this problem this way is because the 2 to the 5th is going to come in to play again later, but we don't have a power rule yet. Okay, so here's what this is good for. Because I can separate 32 into its factors, then I can also separate this log into now 5 different logs like this. And this is going to seem kind of tedious, especially for this many things, so that power rule is going to come into play here in a little bit, and you're going to like that one better, I think. Now the reason that I've done this is because the only thing that I know is log base 4 of 2. And that equals 0.5. So essentially what I can do is replace each one of these with a 0.5, okay? And so a lot of your homework is going to be manipulating the number in the problem using the numbers that you're given. And we're going to look at a whole bunch of examples like that today. So what's my answer when I simplify this? 2.5, okay? So log base 4 of 32 equals 2.5, all right? So you're going to be using your number sense, manipulation skills to try to take what you're given and find out what you are trying to do in your given problem, okay? Questions on that? Let's look at the next property, all right? So that was the product property. What do you think the next property is going to be? Any guesses? Quotient property, very good. The next property is the quotient property, the division property, if you will. And notice here, and that's page 1109, okay, when we have two factors divided, we can separate them using subtraction. And so then again, that is similar to our exponent rules that we already know, right? When I have two exponents with the same base divided by each other, I can just subtract the powers. So that relationship between division and subtraction still exists for logarithms. Okay. Now, most of these are going to be a lot simpler. The one thing I want to show you and point out is that the numerator has to come first. And then the denominator is after the subtraction sign. That order is very important. Log base 2 of 5 minus log base 2 of 6. Okay. Now the kind of problems that you're going to see are more like what I'm about to show you. Alright, so if you want to take a picture of that, you can, and we'll talk this one through. Now this is more like what we're going to see. You're going to be given something log base 4 of 3, log base 4 of 5, and they are approximately equal to these decimals. Okay? And what you have to do is use 3 and 5 to come up with the number that they're giving us. Well, in this case, it's pretty straightforward because it's just 5 divided by 3. So if I'm going to take this and turn it into 2 logs, what would it be?
Log 4 of 5 minus log 4 of 3.
Correct. Okay, it's just log base 4 of 5 minus log base 4 of 3. And so I know what each of those are. I know what the numbers are for this. What is the number for this?
1.1610.
Okay, and what about this one?
0.7925.
Yep. Just substitute it in and subtract. And then we get this. Now, here's what I'm talking about in terms of manipulating, because we really didn't have to do anything. It was already 5 and 3. And the other one we had to figure out 2 times 2 times 2 times 2, etc. Now this one, okay, here's more like a problem you're going to see. I need to come up with 75 using only 3 and 5. And at this point I only have multiplication or division to figure out how to do that. How can I come up with 75 using 3 and 5?
Where do you get the 5 from?
Right here. So I have to use 3 and or 5 to turn this into 75 using either multiplication or division.
There's different log bases.
Oh, it should be a 4, you're right. Thank you for noticing that. That absolutely should be a 4. Alright, Maria, what do you think?
3 times 3 times 3 times 5.
Say it again.
Wait. 3 times 3 times 3 times 5.
3 times 3 times
Wait,
3
how does it work?
times 5. Yeah, no, that doesn't work. Aiden, what do you think?
5 times 3.
5 times 5 times 3? Does
Yeah.
that work?
Yeah.
Sure does. Okay. So log base 4 of 5 times 5 times 3, because that's 25 times 3, right? So, again, this is what I'm talking about with the manipulation. I have to use just these numbers to come up with this. And so now, which property am I going to use to figure this out?
Addition.
I'm going to use addition, but what's that property? Product property, okay? So what I'm really going to end up doing is this and I'm not gonna finish this just for sake of time, but then I would plug this in for the log base 4 of 3, and I'd plug this in for each of the 5s, and then I'd add them all up, okay? So that's more like the types of problems you're gonna see. Yep, plug them in and add them. Yep. Now, in your homework, you might have to combine some properties together. Okay, the key is you do what you need to do to come up with this number using the numbers that you're given, alright? Let's look at the last property. The last property is the power property, and this one is fairly straightforward as well. Okay. When you have a logarithm of an exponent, this power just comes out in front. So notice here, this little power on this number just drops out in front, and then the m no longer has a power on it. And here's the example, okay? Log base 2 of 6 to the 5th, the 5 drops in front, and then the 6 no longer has a power on it. And we're gonna go both directions with this one. We're gonna use this, and then sometimes we're gonna take this and turn it into 1 log instead, without a number in front. And we'll look at an example like that in a second. So here's the example for this one. So we're given log base 3 of 7. So we have to figure out how to rewrite 49 using 7. Okay? Any suggestions? What's the relationship between 7 and 49? 7 squared is 49. Okay? So I rewrite this problem just like that, because 49 is 7 squared. Now what happens to this 2 then? It goes in front. Okay, so note here, and I've got them all underlined, this log base 3 of 7 is that. So I can just substitute in here this 1.7712 right there. Multiply it by 2. Okay? And that's going to give me my answer. Now, for those of you who are thinking 49, well, that's just 7 times 7. Could I just use the product property instead? And the answer is yes, if you wanted to. So had you originally gone into this problem and said, you know what, this is actually 7 times 7. And then use the product property to separate, you could do that too. And you're going to get the same answer. Because in reality, this is 1.712 plus 1.712, which is the same as multiplying it by 2. You'll get the same answer. The key thing for your homework tonight is, I don't care which property you use. You use the one that you're most comfortable with. That being said, when you go to solve some of the equations that we're about to do, there are only certain properties that you can use. Okay? Otherwise it won't work. So let's look at the next phase of it. So we've introduced the properties. Let's use those properties to solve some equations. So here's the first one. Oops. Oh no, let's talk about this one real quick again. We already did this. We already know the answer. But I just want to show you that, yeah, it would have been nice at the beginning to have that 2 to the 5th. So if I would have rewritten this as 2 to the 5th instead, and have that 5 drop out in front, you still get 2.5. Yeah. So had we had the power property at the beginning of the lesson, this probably would have been a little slicker than having to add 0.5 a bunch of times together. Okay?
I like that one a lot better.
And what I'm telling you is, it's up to you which one you want to use now. Okay? Let's get to equations. So now we're going to use these properties to solve equations. And this is similar to what you just did on your test. Okay? Except we were used to seeing 2 types of equations. An equation with 1 log and an equation with 2 logs. Now we're going to start seeing with the equations with 3 and 4 and 5 logs, and we're going to have to get them back down to log equals a log. Okay? That's what we want to get. We want to turn it into a problem that you already know how to solve that we did in 7.4. And so what we're going to do is use our properties to condense each side down to 1 log, and then we can solve it from there. So let's talk about the left-hand side first. Okay, let's talk about just the left-hand side. All right? This has a number in front of the log, so I need to get rid of this number somehow. What do I do with it? Okay, so this 2 then comes in as the power on x. So we're working the power property backwards now. Okay, what about on the right hand side? What property am I going to use here?
Multiply together.
What am I going to multiply?
Product.
What am I going to multiply?
Product.
3 and
27.
27. Okay, so I can condense each side down to 1 log. And what that's going to look like is this. Okay, log base 7 of x squared, just by moving that 2 in, equals log base 7 of 81, just by multiplying 27 and 3. Okay? So now I have it as log equals log. So now it's just like what we did on your test. What do I do next? Yeah. Get rid of the logs. Just set the x squared to 81. So how do I solve that?
Square root.
Square root both sides. What else do I have to do whenever I square root both sides? Plus or minus. Okay, then you have to check. Whenever there's 2 logs, you have to check. And I only have one place where I need to check, because there's only one variable in this problem, right there. Are we good? 9 and -9, both of those work? How many think they both work? Raise your hand if you think they both work. 9 and -9, both there in place of x. That works fine. Yeah? If you didn't mess that up on your tests.
Why wouldn't it work?
What can't the x ever be?
Negative.
Negative.
Let's go.
That x can't be negative there. It can't be 0. It can only be positive. So if you plug negative number in here, we got a problem. So I have to throw -9 out. There is only one solution. It is 9.
Can never be negative.
Correct. Okay? So be careful on that check. One more. Okay? The right hand side's already 1 log. We're good shape here. We don't have to do anything. What am I going to do? How am I going to turn this left hand side into 1 log? What property am I going to use? Quotient property. So what will it be? Log base 4 of what?
48
48.
minus n.
Nope. Over n. Okay, over n. So when it's subtraction, we got to flip it to a division problem or a fraction. And now I can drop the logs. So go ahead and finish it. So I dropped the logs. 48 over n equals 6. Now, here's where some of you just want to start doing instead of thinking. Okay? And I need you to become a little bit better thinkers, right? You're trying to figure out, how do I get that n out of there? I got to multiply both sides of something, blah, 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 and all that algebra stuff that you learned, instead of just going, okay, what is this really asking me? This is saying 48 divided by some number equals 6. 48 divided by what number equals 6? 8, right? You know that, but you try to start doing instead of thinking. Sometimes it's super easy, right? You all gave me 8 pretty quickly. So look for that kind of stuff. Yep, n equals 8. I got to check it. Any issue here with this being 8? No, it's fine. It's not negative. We're fine. How many had that? All right, that's good. And that's it. Whenever you check, and I've been talking about this all year, whenever you check a solution, any kind of problem that you're checking, always go to the original equation. Okay?